Humoral immunity involves antibodies and B cells. So the term humor just means fluids. Humoral immunity derives its name from the fact that immunoglobulins float in blood, the humor of a body. Whereas cytotoxic immunity targeted mostly viruses and bacteria, humoral immunity targets mostly allergens and bacteria. But no matter what, the first step is for a pathogen or the allergen to enter into the body. This can happen in a lot of ways. This picture here shows the allergen fitting between the epithelial cells that line an airway, and it fits right between those tight junctions. A dendritic cell that's roaming in the area, it drinks some of the interstitial fluids by way of pinocytosis, and it inadvertently consumes the allergen. And immediately, the dendritic cell ingests and then digests the allergen and displays its epitope on the MHC class II proteins for the world to see. So this dendritic cell, it can't directly communicate with B cells and say, hey, I found this thing. Maybe you want to, I don't know, make some immunoglobulins? But it's a helper T cell that can facilitate the communication between the dendritic cell and the B cell. The helper T cell interacts with the dendritic cell, and then it searches through the B cells in a lymph node, trying to find the right B cell that displays the right immunoglobulin that fits the allergen epitope that the dendritic cell showed it. Once it finds the specific B cell, the helper T cell then stimulates the B cell to differentiate. B cells are formed in red bone marrow where they mature and become immunocompetent. This is different than the T cells that matured in the thymus. B cells can also be found in the liver, surprisingly conferring allergies from a liver donor to a liver recipient. These are the cells responsible for producing antibodies against foreign antigens. Once a B cell is chosen or exposed to a foreign antigen, it becomes activated and it undergoes mitosis or cell division, creating this cluster that you see right here. One of the daughter cells becomes a memory cell. And that's why you can be resistant to reinfection of things like chickenpox once you've been exposed. These memory B cells, with the right immunoglobulin inserted into their cell membrane, can live for up to 20 years or longer. The other cell, which is called a plasma cell, has a different fate. Plasma cells will continue to be produced by the B cells, creating another army of plasma cells. So each B cell turns into a plasma cell and goes on to produce antibodies that are secreted into general circulation. And these antibodies seek out and mark the antigen for destruction. Antibodies can only mark the target cell. It can't actually destroy the target cell. It can mark the target cell, causing a bunch of them to clump together. It can smother the surface of the target cell, making it more tasty for a cytotoxic T cell. Immunoglobulins, they can act like beacons for complement proteins and other phagocytes. And then immunoglobulins can even cause toxic cell byproducts to like precipitate out of solution. So even if there are no T cells present, an immunoglobulin might be able to make granzymes and perforin precipitate out of like nowhere, out of fluids. So these immunoglobulins, they sound great, right? But there's limitations to your defenses with immunoglobulins. B cells can only detect an obvious threat. So they can only detect things that are allergens, which one allergen is the entire epitope. B cells can only detect bacteria, where it has epitopes inserted into its plasma membrane. Same with parasites, even viruses, right? But they cannot directly attack another cell. They can only mark a cell for destruction. Another thing that immunoglobulins can do is they can be part of creating what's called allergies or sensitivities. In this picture here, you see a plasma cell secreting antibodies that are then inserted into the cell membrane of this mast cell here. Now, when the mast cell that's positioned in your tissues, instead of in a lymph node, when the mast cell encounters the allergen will bind with the immunoglobulin on the mast cell and cause degranulation, which is the release of histamine and heparin. And this is what causes what you would call an allergic response, right? So atopic dermatitis is an allergic response. Allergens enter into the skin and mast cells degranulate. Anaphylaxis is systemic degranulation of mast cells. It's not a few of them degranulating in your arm. It's all of your mast cells everywhere degranulating all throughout your body. Just as cytotoxic T cell immunity had a first and a secondary response, so does humoral immunity. In the initial response or the primary response, that happens when someone first encounters an allergen or antigen. For example, peanuts. Eating them for the first time might cause an itchy throat, which is a sign of a primary response. However, the secondary response, or the second time you eat peanuts, occurring is a subsequent exposure to the antigen. That's when anaphylaxis becomes a risk. Memory cells, without repeating the cloning process, immediately produce immunoglobulins to trigger a systemic and a strong immune response. And it's essential to understand that a full blown anaphylactic hypersensitivity requires at least two interactions with the antigen, B cell and CD4 T cell. Another diagram in your textbook illustrates the difference between primary and secondary immune responses. The primary immune response is slower, right? The hump is not as high, but it's also a shallower gradient on that first hill there. It takes weeks to reach antibody levels. The first attack is short lived. In contrast, the secondary response produces higher and longer lasting levels of immunoglobulins. Immunoglobulins such as IgMs and IgGs play very critical responses in hypersensitivities like anaphylaxis. These responses, they differ from the responses of cytotoxic T cells that might target pathogens like viruses. Now, in the case of somebody receiving a liver transplant and receiving myeloid stem cells that create a peanut-specific allergen, that person may eat peanuts a week after their surgery, but they wouldn't feel a primary response at all because they most likely would have been prescribed prednisone. And we know that cortisol is an immune or an inflammation suppressor. And therefore, somebody who may have received a peanut allergy in the donation of a liver might actually acquire that peanut allergy. And then the second time they eat peanuts, they enter into full blown anaphylaxis because they have no idea that they already had a primary response while they were under the corticosteroids. This is a really nice diagram that centers on humoral immunity, and it has some of the things that we've been talking about. So, first off, you can see a dendritic cell here is actually reaching through the tight junctions of these epithelial cells, and it's grabbing an allergen. You can also see the dendritic cell here doing phagocytosis. And then over here, that dendritic cell is presenting what it found to a T cell, right? Because we know that dendritic cells can't directly communicate with B cells. So this naive T cell is like, oh my gosh, you found this? Thank you for showing this to me on your MHC class 2 receptor. You can also see a little co-stimulation happening in there. And then this naive T cell, it diversifies into a whole bunch of T helper cells that then go and search through lymph nodes trying to find a B cell that displays the correct immunoglobulin. Once it finds that correct B cell, it's going to make an army of plasma cells that will then create all of these immunoglobulins. Now, these immunoglobulins, they then get inserted into mast cells that are in the tissues, and they lie in wait for the second time the allergen enters into the body. And that's what you have here. This little pathway here is the second time the allergen enters into the body. And what it does is you can see it right there connecting with the immunoglobulin that's been shoved into the cell surface of the mast cell. And so this mast cell starts to release histamine, heparin, cytokines, and it draws other cells to the area of disruption. And again, as I said, this can happen in just one specific area of the body, but when all mast cells encounter the allergen for which it's been primed, all of them, that's what creates anaphylaxis.